Okay, I'm going to attempt to kind of go over these so that they're a little easier to understand. So radical expressions, we talked about those last time. We need perfect squares. So a perfect square, 1 is a perfect square because it's 1 squared, and then 4 is a perfect square because it's 2 squared. So when I talk about perfect squares, I'm talking about the numbers on the side. Okay, so when I simplify a radical expression like 80, I'm looking for something over here that goes into it. So what I honestly do is I take this number and I find the number just below it. So 64 is the next one. And I realize that you would know that 80 is not divisible by 64, but that's just where you start. And you'd go 80 divided by 49, and then you keep going until you find one that will go in. So if you take 80 and divide by 49 and then 36 and things, you end up that 16 actually works. So this just gets broken into two different things, the square root of 16 and the square root of 5. Because if you multiply those two together, you get 80, okay? So then this first number is a perfect square, so then it turns into 4, because the square root of 16 is 4. This one can't be broken into anything like a whole number, so then it just comes down. Then the same thing with this one. I looked for perfect squares that will go into it, and I found that 9 goes into it. So 9 times 6 is 54. So the square root of 9 is 3. And then that one just comes down. Same thing with this one. And this is in your notes. Okay, then you'll have things where you'll have 2 square roots. Well, neither of those have perfect squares, so you multiply them together and you get square root of 28. And then you use your perfect squares again, and you find that 4 and 7 multiplied together is 28. So the square root of 4 is 2. And then the square root of 7 just drops. Same thing with this. Neither of these have a perfect square, so you multiply them together. You get 50, then square root of 25 and the square root of 2. Okay, then we have things like this. So x squared can be written as the square root of x squared can be written like this. And what it is in order for something to come outside, you have to have 2 of it. So like up here, 4 could have been written as 2 times 2. So because there's a group of 2's, they could come out. So then here, there's one group of x's, so they can come out, and then the answer is just x. There's no square root anymore. So then x to the third, there's 3 of them. So there's only one set of 2, so that answer comes out, but then there's 1 still left. So it has to stay there. Then 4's, there's 2 sets, so that comes out. So if you notice, this one has no square root left, and it's to the second. This one is to the third, and it has a square root left. This one is 4, so if you notice 2, 4, and then 6, you should be able to pull whole groups out instead of having any left under there. Then you'll have things like this where you can pull one group of x's, but an x is left. Then you can pull a group of y's. So a group of x's, group of y's, and then there's an x still left underneath. Hopefully that makes sense. Then, putting those kind of 2 things together, I split 90 into 9 and 10. The square root of 9 is 3. Then 10 can't be broken again, so that would go inside the radical. And then I just wrote these out, and you don't have to do this on your assignment, but I'm just showing you why. So there's one group of x's that comes out, so that's where this x came from. There's one by itself, so it has to stay underneath the radical. Then we have 2 groups of y's, so that came out at y squared. Then we have 2 groups of z's that can come out, and then one of the z's is left. Okay, and then on this one, same kind of thing. This right here is not in alphabetical order, so then I just reordered it down here. then you should be able to look that one up, okay? Okay, so last thing. When you have something like this, you cannot have a square root in the bottom in the denominator. So first thing you want to try is reducing it. So you can reduce those both by 5s. So then it became 7, square root of 7 over square root of 3. Well, we can't have that square root of 3 on the bottom, so in order to get rid of it, we multiply it by itself, and I'll show you why. So if I multiply the bottom by square root of 3, you also have to multiply the top. Remember, we have to keep things balanced. So when you multiply those two across, you get the square root of 21. Then square root of 3 times the square root of 3 is the square root of 9, which the square root of 9 is 3. So if you notice, if we multiply a square root by itself, it just becomes the number without the square root. So hopefully that makes sense. Here we reduce 6 and 12 to 1 and 2, and the y is still there. Have to multiply it by the square root of 2 on the bottom. So then the top is 1 times 2, which is 2. The y comes down, and then it's the square root of 4, which is 2. Okay? Okay, then finally, and we'll kind of go over this more next time, but when you have square roots, it's kind of like variables. You can't put them together until they're the same number. So you have to break them like we've been doing, and this turned into 9 square root 5. This one to 2 square root 5, and this to 7 square root 5. So now, because they're all the same square root 5, you can just take 9 plus 2 minus 7, and you get 4 square root 5. And your assignment is the worksheet.